Welcome to those of you who just got the notification. Thank you for joining us for our inaugural podcast about AI, the revenue revolution. We're about to kick it off with the CEO of Bridgeline, Dr. Ari Kahn, and he is being joined by the EVP of Products and Strategy. So let's go ahead and see some faces here. Welcome, you two. I know we're going to go ahead and kick off the conversation, and we'll go ahead and see you guys a little bit better here. And if you just want to very quickly give our listeners an overview of what you want to cover, and then just get straight into it.
Great. Well, we are in the midst of a lot of very exciting technical advances in AI and at Bridgeline, especially around HawkSearch. And technology is great, and we've got tremendous capabilities. But if you don't direct technology towards concrete customer needs, then it ends up just being a hobby and not a business. And we want to, as a mission for the company, drive revenue for our customers by increasing conversion of their site visitors into buyers, increasing the average order value for each one of those buys, and driving more traffic. So what we will do today is talk through some of the customers that we have and what their needs are, teasing out commonalities as to how we can add value. And in the midst of that, we'll be bringing some of the technical advances with large language model embeddings and vector databases and some of the other AI specific capabilities, as well as some other capabilities that we've built to light, and find a way to implement those in the most productive way for fulfilling our customers' revenue needs.
I'll just add to that that I'm looking forward to this conversation. For people who don't know, Ari has a PhD in both computer science and artificial intelligence, but he's also the CEO of the company. So a great combination of technical knowledge and background and business approach. So yeah, looking forward to it.
Me too. We've got to direct that pedigree towards specific problems, right?
Exactly.
So we have hundreds of customers that have, huge product catalogs. They've got varied customers of their own in both a B2B and a B2C setting. And a lot of them are very close to us. We have active conversations led by John as to what our product roadmap is and what their needs are. So let's talk through what some of the even things that we've spoken about recently, some of the concrete needs are that we're seeing from the customer base, and see if we can find some patterns there as to how to develop the product farther.
For sure. One word that I like to use is engagement. And the reason why that word I think is so fitting is when you consider the world today, all the distractions, everyone trying to get people's attention, even when you consider web property, to go to many websites, even websites for our customers, there's advertisements, there's billboards, there's numbers, there's offers, etc. But when you really have someone's attention, when you really know they're engaged, is when they click on the search bar. Now you have their attention. And Ari brings this up a lot, and I love this concept, which is if someone comes into a store, a brick and mortar store, it's very easy, so to speak, to have that conversation, to understand what they want, to understand the context of maybe the requirements they have, even though it might not be clear in their head. And in that kind of situation, you could really help the customer find what they need, this idea of engaging. But on a website, it's this bar. It's like this little bar. How can I fit the knowledge, the context, the experience, and all of the information that might be in that salesperson's head within the bar? And it's so important to do it because you only have a little bit of time to engage with them. So as soon as you start clicking into that bar, that's where the engagement starts.
Right. It's amazing. People are so versatile and so intelligent that we don't even realize all the amazing things that we can do and how we adapt to our environment. And online consumers have unknowingly begun thinking and behaving like a computer, and they're guessing at keywords and entering incorrect sentences because they just know that they really need this noun and this noun and so forth to hopefully hone in on the product that they want. And it's a very inefficient and non-human way to interact. And you would never walk into a store and just walk up to a salesperson and say, blue tennis shoe, and see what they, produced, right? You would say, I'm really looking for something that's a little bit more comfortable with what I'm wearing right now. I'm a size 9. I like blue, but, I'm not hung up on the color so much as I want, something that I will play tennis with and so on. And then that customer will take that context and a deeper understanding of their product catalog and so forth, and have an interactive communication. And this human machine interaction needs to evolve in the other direction, where machines start acting and understanding more like a human, and we can stop acting and behaving more like a machine. And that's what large language model and vector databases, not to get too much into the details of it right now, but that's the opportunity that they produce, where you go from a keyword-based conversation that you would never have with a human being in a brick and mortar store to a conceptual one. And one of the other amazing things with the conceptual capability is that it's contextual, which means that the understanding, the concept behind a sentence is based on the context in which that sentence is being used, and also with the evolving information that's happening in the real world. And if you've got a system that is monitoring social media and noticing trends, it's able to do things like, I want to just buy the coolest shoes. My kid is 15 years old. I don't know what those kids like, but just, can you show me the tennis shoes that 15-year-old boys are interested in, that my kid will be happy I came home with, right? You can't do that in a search dialogue on a typical website. You can definitely do that with a 20-year-old kid working at Foot Locker when you walk into the store. And tomorrow's search dialogues will allow that also.
Yeah. The biggest insight, and sometimes it's the small things that give you the big insight, was when I took a step back and not only understood how the vectors, and now we're getting a little bit into the weeds, but I'll pull back out in a second, worked from the system perspective, because we always hear that term large language model. It's like, the system has analyzed billions, if not trillions of documents, and have come up with a model, a vector, a set of coordinates that it understands how this world works. So we can talk about that. We'll get into more details. It's kind of interesting. It's sitting here ready to be queried. But here was the insight that really made it interesting for me. How do you query that system? And the thing that just blew my mind is, normally when we think of that bar, that search bar we were talking about before, and you hit the submit button, you would think, it takes the words and it puts it into a database. Think back to Oracle, think back to IBM, the database. And that's why we always had that, no, it's the keyword, because it finds those words. But in the model, that large language model, when you talk about vectors and we get into that detail, those individual words mean nothing. The question also has to be converted into that vector. And it was just something I never considered, that it's interesting the way these APIs work, to say like, oh no, I'm not making a keyword query, I'm making a AI driven query, I'm making a vector query. The first thing it does is I have to convert that into a vector. Now it's talking that same context that you were talking about before, and then saying, okay, now within this world over here, here's my vector, which represents the question. It could be the words that were in the question. It could be the picture that I'm dragging into the screen. It could be the song that I was listening to at Shazam. It converts that into a vector. And then it runs a relatively straightforward mathematical model to say what other vectors are close, if you will, to this vector. And that's when, for me personally, that's when the light bulb went off to say, now I think I understand a little bit of NLP. Both the system is built up with these vectors and understanding the world, but you have to make sure you convert the question as well. So now we're all kind of talking the same language. That's how it understands the concept.
Yeah. So here's the amazing advancement that has very much leveled the playing field between smaller businesses and larger businesses for innovation. And what that is AI as a service, so to speak, where these large language models, which are neural networks that have ingested billions or trillions of documents in order to create the neural net weightings and understandings that can really convert, they can create a concept from a picture or a sentence and so forth as a vector. And the fact that you have OpenAI and Google, IBM Watson, and so forth that have invested in, I think in many cases, billions of dollars in training and developing these large language model neural networks that create embeddings, allow companies to then just access that embedding as a service and do interesting things. And that's why you have to think in terms of customer needs first, because you obviously need to be very technical and to have a certain skill set to use those, but you don't need $1 billion in order to get rolling down the AI path. So to elaborate a little bit on what John just said to some of us that aren't as close to large language models and vector databases, embeddings, and so on. So you have a large language model, which is a neural net. I won't get too far into that, that has ingested all this information. And now when you give it a new piece of information, it might be a picture, it might be a sentence or an article, it's able to take that and create a vector. So a vector is just a sequence of numbers. And in the most simple world, let's just imagine that our vectors are two-dimensional vectors. So it's just an x-axis and a y-axis.
Think latitude and longitude for a location.
Longitude.
New York City.
Boom.
Two numbers, and it tells you exactly where New York City is.
Perfect one. That's a great. Yeah. That's a great analogy, right? Or it's not even an analogy. It's a real example of a two-dimensional vector, right?
Because someone figured out this is the way the world can be broken up, and now I can understand these 2 points, and it's a specific location.
And an LLM could have learned that by having given a bunch of training samples of a city name and position on a globe, and it would have gone through iterations and trained for that. And then now you have another city, which is Buffalo, New York,
yeah,
and another one which is Paris, France. And these cities, which have a longitude and latitude, just exist in this two-dimensional space, and some of those points are closer to each other than others. The Buffalo, New York, and the New York City one are pretty close, and Tokyo and Paris are pretty far away. And that is how simple we're able to go. We take any sort of a sentence, New York City, for example, turn it into a vector, and then you just draw circles around that vector, more or less, to find what other vectors have landed closest to it, and that is your best match. Now, the language models that we're talking about have hundreds and sometimes nearly 2,000 numbers inside of dimensions inside of that vector. So now you have to get your head around this high dimensional space and computing the distance between 2 points in that space. But actually that computation is really simple. It's just like the Pythagorean theorem, it is in these other, in a multidimensional sense, and you're just finding all the points. That's a vector database. That gives you the ability to basically have memory as to what concepts or what products or whatever are in your website needs to be able to find, and then anyone else can drag in a picture, they can bring in a sentence, they can give you a video clip, you run your large language model betting against that, it gives you a new point, and give you all the points that are close to it. That's my search result.
Yeah, it does blow your mind, and you understand fundamentally the math more than I do, but it would be funny, let's say we do use this two-dimensional world, and you're in Buffalo, and I'm down here in New York, and I say, all right, you should come down, visit. So you come down, and you look around, and I'm not there. And it's like, where's John? I said, I forgot to tell you, I'm in a balloon 500 feet above. So then if we said, oh, you know what, we're missing a dimension. We should add one more dimension here. Then I'll really know where you are. Right now I have 3 dimensions. And when you were saying before, some of these models have 250 dimensions, thousands of dimensions. You can imagine how accurate it is when it tries to understand it. Of course, the problem is, just for a mind like myself, is like, what is the dimension number 372? Mm-hmm. And it's like, you can't understand it, but somehow this large language model does understand what that dimension is. It's not that way, or that way, but it's something else.
You know, that's a fundamental challenge in neural nets. So if each one of these dimensions is sort of a weighting in this neural net, fundamentally one of the criticisms in the old days for neural nets, I guess it's a legitimate criticism today as well, but people aren't as hung up on it, is that as you keep training a neural net, you show it a piece of information, and then you give it a positive or negative feedback as to whether its output was consistent with that information was, you end up with these dimensions and these weightings that don't represent something that you can necessarily put your finger on. You can't say that dimension 400 is the color of the object and dimension 401 is the size and so forth. They are, and if you even just train your neural net in a different order, or even in the same order, because there's a lot of randomness, you could end up with different dimensions meaning different things. And that's okay. You don't have to have sort of a human understanding around each dimension. What matters is that it is tuned for optimal matching in that particular domain, and the actual human concept behind each dimension just doesn't exist at all. And it really kind of throws you off. And it's like, but I want to know what dimension 1 means and so forth.
I want to know why it returned that result.
Yeah, and that is part of that criticism on neural nets, is that you can't explain why it returned that result. You can train it more and help it get better results. There's a funny term that's used with large language model called hallucinations, right? So a hallucination example, you keep asking your large language model to do math. What's 5 plus 6? 11. What's 5 plus 2? 7. What's 1 plus 3? Green. All right, answer doesn't make any sense at all. That's a hallucination. And you can't look at the underlying network and understand, well, how come it just knows how to add every two numbers together, except it thinks that those two is something that's not even a number, and you just have to train it a little bit more and get it.
Well, you brought up a point, Ari, in the past, which is maybe some models have too many dimensions. And the question is, what is the right number? And that's something that's learned over time. But I will say, some of the most interesting models I've seen have 250 dimensions, in that range. Of course, we've used other ones in the 1500 range. We really haven't used the thousands, or way into the thousands. But maybe sometimes there's too many dimensions, and it does create that confusion.
Yeah. More is not always better in a particular domain. You run into performance issues when you have a large number of dimensions. You've now got this giant high dimensional space that you need to find your points in. You have excessive training needing to balance all of those dimensions, and you just might not have enough content to come up with something that's efficient. And you have just randomness and errors that live in this giant dimensional space that you can never really fill in the gaps over time. So more is not better. I mean, whales have bigger brains than humans, but I think we're smarter than whales. And we might not be. I've never spoken with a whale, but
I think you are. I think you are.
So going back to customers, what are some just specific examples of challenges that customers have come to us with that we might be able to solve with these?
So probably the biggest issue we deal with and complaints that people have is searches with no results. Like, nothing is worse than that. So the simplest way to look at the world is people put in words, we get responses, they look at the responses, and we have reports and data and everything else that shows you here's how the site is working. When there is a search that does not come back with a result, it's the bane of their existence. Like, it's the worst thing for a merchandiser using our tool to happen.
Right.
And the question is, how many more things can you run your system through in order to find that right thing, and or just either redirect or something else? And the question is AI that next thing? Is the vector to say, look, I tried this way, it didn't work, it didn't return anything, now let's try the vector? And now we're starting to get into, like, are we saying vector databases replace the keyword systems? Like, where do these things fit together? I believe generally they're complementary. Mm-hmm. There's going to be some activity that always occurs over here. There'll be some activity that always occurs over here. There'll definitely be blended models. Like, well, I'm going to run this one. Oh, interesting. Not what I was hoping for. Now let's run this one and see what the response is. But that's the need. How do I avoid no results found?
Right. There's a concept that's often used in AI called sensor fusion. A lot of times this might be used in navigation technologies, missile guidance, or automated vehicles, so forth. But you'll have lots of sensors. You will have a laser rangefinder and sonar and GPS and visual guidance system and so forth. And they all have slightly different information as to, for instance, how to get from here to the corner. And you need to fuse that information.
Yeah.
In the same way, the keyword-based searches, they actually work pretty well. They don't solve every problem.
We love it. We love them.
Yeah, we love them, and they've been tuned and can do a lot of stuff, but it's not the only solution. And large language models may not be the only solution either. And we need to be able to fuse those results. And I think that there's still a requirement for a human aspect to be able to tune how they're fused so that your merchandiser is like maybe setting, some parameters as to which results to put on the top in different circumstances, the AI ones, the keyword ones, or some combination of both.
Yeah. Now there's another additional aspect. So up to this point, we've been talking about that search bar. It's critical. The conversation will continue. But there's another important feature, and this was something new that I learned about HawkSearch when I started, which is this idea of a recommendation. So Bridgeline has three main goals. How do I get more people to your site? How do I help those people convert more, these people coming to the site? And how do I increase the average order value? So I think the first part is another conversation. The second one we're kind of talking about here. But the third one is, it's always like that. You want fries with that? How do I suggest to someone on a page, a product page, a checkout page, something like that, the absolute perfect product for them to say, yeah, I'll add that to my cart. And that requires, as we're saying here, a real knowledge and understanding. What have they looked at before? What are other people searching for?
Yeah.
That analysis. So it's not a search. The data that went into it were things that people were searching for, but it's basically saying, I've looked at all the activity. Now I'm going to make a recommendation. And the better the recommendation is, that's the more average order value you're going to get from your visitors.
It's interesting because if you are having a natural language interaction, then the context or the reason why someone's buying something. So, Amazon does a great job at people who bought this also bought that. And that's helpful.
Yeah.
But that's almost like keyword kind of level of intelligence.
Yeah.
Because you don't know why the person's buying a wrench. And if you actually, if the person typed in, I need to fix my faucet.
Yeah.
And I can't unscrew the tab. And your large language model returns, get this wrench, then it also understands the need and is able to say, people who used a wrench to fix a faucet often found out that they needed a washer as well.
Totally.
And they can sell that, right? And that's not people who bought this also bought that. It's like people who solved this problem ended up, having to use this as well.
And to your point, it's always, and we've kind of used this when I talk about recommendations, I say, who do you ask for recommendations in your life? Not site search, but in general, someone who knows you, because they know everything about you. They know your tastes, they know your interests, and all of that context is what's important. And to your point with the, people who bought this also bought that, I'm sure you know these stories that Home Depot and others talk about, which is when there's a big storm, put Pop-Tarts out. It's not because people bought, this lawnmower thing, they like Pop-Tarts. It's like, no, there's more context here. Yeah. Is there a storm coming? Did something else happen? And when you really start to leverage what AI can do, you're really trying to understand the context, that concept, as much as you are in the keywords. And one thing is, you were asking, what do people ask for? One thing we always run across is, how can I segment and target my visitors? And it's tricky. It's like, well, I don't know, like you always know, and we have tools that will help you. Maybe I know your IP address. I know what time of day it is. I can start to try to segment people. But where it could get interesting in the future is, I see the way you're asking questions, and I might be able to infer something like, sounds like you have kids, or I wonder if you're, whatever that segment could be, because now we understand the context beyond just the keywords that you're searching for, because we're letting you kind of be a little more free form. Ask your question with a couple more words, the way you phrase the word, how long your questions are. We can start to get more context. And the more context you can get, then you can be smarter in these recommendations. And basically presenting the right information to the right person.
Yeah. That's really interesting, right? Do they really put Pop-Tarts out?
Yes.
Really?
Oh, yeah. Because the people doing the analysis, to your point, yes, they definitely look what was in your shopping cart. But then they start feeding in weather data. They start feeding in all this other, was there a holiday coming up? Are there other national holidays or whatever it might be? And they have these scenarios where they see that when there's a storm coming, people get in a panic, like, oh, I need a little bit of a comfort food, and I'll just throw that in there and add it.
That's interesting. So, all of those dimensions inside of the embedding vector, although they don't represent something specific, can indirectly reference different types of concepts, context. And the wrench in a broader context of there being a storm, and a wrench in the context of I need to fix my faucet, will actually have different points in that vector database.
Yeah.
And then when you come in, you say I need to to do something, and it's also augmenting your ask with weather information and other stuff. Then that means that the vector that results from the from your ask now incorporates dimensions that represent the weather, and it brings a different search result. So that's really amazing, where your website will suddenly have all of these feeds. A weather feed could even be following certain influencers, stock market, right? Yeah, it's like it's pretty, there's all sorts of fun things, analogies you could have on that, right? And then with personalization, and the site knows who you are and what your interests are. Yeah. It could actually be weighting those feeds that are interesting to you differently than the ones that you just don't care about, and coming up with different results when you ask a question than it would produce when I asked that same question.
Totally. It's what I love so much about using the term neural network when we kind of talk about these concepts, because yes, it is conceptually the way the brain works. And we always hear these stories that when we think a memory, like, oh, I just remembered something, someone told me something, we just don't realize there's like so many additional things around me that are occurring. Oh, it was a beautiful day that day. Or, I walked past some dog poop or something. The point is, all of these inputs are going in. People often say, like, it's actually smell that brings back memories because I didn't think about it, but it's true. Mom was cooking food that day and it smelled great, and that kind of reminded me when I smelled it. That all of these inputs, all the context that we're talking about here, helps you with memory and returning kind of a memory or a thought in your head. More and more of that, whether it's the weather feed, whether it's the stock market feed, or who knows what, is going in, and these systems will get smarter and smarter.
Right, and it's more than just the real-time feeds, but it's also a built-up context from the last thing that you asked or saw, and the one before that, and one before that. So now the actual input is not just the sentence that you entered, it's not just the weather at the current time, but it's also the last results that were returned from your previous query, and the query itself, and so on and so forth. So if you ask the same question twice, it will not give you the same answer, because obviously you didn't find it the first time.
Exactly.
Just imagine with a human, it's like, what time is it? What time is it? You're not gonna, like, the first answer was something.
You got to think, you mean something else.
Exactly, right? Yeah. So that's pretty amazing. Now, we've got B2B and B2C customers that often have different behaviors of their customers themselves. And the B2B universe is often professional buyers that are repeat purchasers of the same products.
Yes.
Have very specific information and know a lot about the products that they want to buy. So it's less of a fuzzy query. What are some of the things that they need, and how is that context and concept versus keyword balance
Totally
different?
Yeah, and that's why keyword, I know we're kind of talking about specific words, but it's funny because especially in the B2B world, A SKU is sometimes like the most important thing that they're searching for. I know your product catalog. This is the SKU I want, which is a keyword, which, by the way, is why that type of search is never going to go away. And the amount of logic, we could spend a whole other session just talking about what we can do with a SKU, with understanding, like, was that a slash or a dash, or did you put a space? Anyway, the point is, admittedly, in a lot of cases, B2B is saying, don't mess with my SKUs, because someone's going to come in, put in a SKU, and that's great. So terrific. Like, not get rid of that. That's so important. But when we start talking about the other things, to say, like, by the way, just so you know, that manufacturer has some other new interesting products you might want to check out. So in some cases, it could be the AI is on the recommendation side. So when you got to that product, I don't want you not to get to the product page. Like, we want to make sure you get to that page. But now it's like, by the way, there's another version of that, the latest whatever it is for that manufacturer. You might want to check it out. You don't have to, but you might. And then guess what? It's like, oh, that is interesting. Let me check it out. Now you've started to engage that visitor a little bit more. There could be some other opportunities.
Right. The recommendations in the B2B space is very interesting, because as we're building up that personalized history and context, it could even become intelligent enough that it's like, on Tuesdays, you usually order SKU 48, and that wasn't part of your order. Did you forget something? And all of a sudden, your that recommendation is producing a larger order. And so
I'll give you an example. This is an actual customer where the world of the offline, so to speak, that brick and mortar, or just the phone call, and the online world merge. So we do have customers that say, we have a lot of people that still call in. Okay, they're going to order those products. Great. But we're trying to move them to the website. But I want the website experience to be personalized, meaning those search results based on what you did before. But I have all the data from the phone call they made, or they've submitted it through whatever. So can't you take that feed, put it into your machine learning? And the answer is yes. Of course, the bottom line is we got to make sure we know who this person is when they log into your website. Let's just make sure the identifier for that individual is the same as the identifier in your ERP. But if it is, we can definitely show on this is Tuesday, you always order on Tuesdays. So it's interesting. You can kind of take the knowledge that you have offline, so to speak, and then move it to your online world and take advantage of these personalizations and the machine learning, even though some of that activity is still occurring offline.
That's really interesting.
So I do want to pause really quick, because we did just hit 30 minutes.
Okay.
And I do want to just jump in real quick and mention you guys are right on the brink of dividing up the approach of AI and recommendations and the difference between B2B and B2C. And I think that would be the perfect place to pause, because
I a whole segment on B2B versus B2C, don't you? That's multiple segments. That's a very interesting conversation.
Absolutely. And I think that alone, I mean, it is a little bit of drinking from a fire hose. Not all of us have PhDs in this. So I think we're going to pause there. And I think the next session that we have would be so helpful to divide the strategies, whether it's recommendations or what we're doing with data, between B2B and B2C, because I know both of those arenas are so helpful for our customers to understand the difference of. And there are some of our customers that live in both worlds. So with that, I know you guys are on a roll.
Let's wrap it up. Yeah. Well, we'll keep on talking offline. You can record the next one.
There we go. Yeah. But I'm going to go ahead and put this up on the screen. So for any of you who did listen through and you made it all the way to the 30-minute point, if you do want more information, you can scan this QR code and actually learn a little bit more of HawkSearch's capabilities, or the larger Bridgeline suite of tools that we have. But with that, I just wanted to thank you too. I know when you get going, it's hard to put the brakes on, because there's a lot of good content here. So I think this will definitely be an ongoing series. All right.
Cool. Great. Thanks,
Victoria. To be continued.
Thanks, Ari. Okay.
Thanks, John.
Thanks, guys.
Bye.